In this particular module, I wish to discuss about a certain facility, that is transfer station, meant for municipal solid waste management. Under this, we will discuss about the definition and scope of various activities, criteria for location of transfer station, advantages and disadvantages of the facility, factors affecting design, some pros and cons of various design alternatives, and associated costs and economic analysis. As you learn the content, you will be able to explain the importance of transfer station in municipal solid waste management, state available design alternatives with their advantages and disadvantages, and will also be able to carry out the economical analysis of the alternative. In last few presentations, we had just focused on the collection activity. So after knowing most of the features associated with this particular collection activity, we can move to this next functional element, which is transfer and transport. Please see that we wish to move the generated solid waste at some of the destinations. That means at each of these particular functional elements, it is expected to have collection, storage, and subsequent transport. Hence, though we are dealing with this particular term transport as a part of these various activities, one should not confuse. Now, at this particular junction, we wish to have that particular collected waste transferred to some activity. Hence, here what we need is transportation mechanism in between these two. Whereas, after doing whatever you want to do at this transfer station, further the processed waste needs to be again transported to some processing facility, as well even some disposal station. Hence, the transport part is inevitable, and that's why we deal with the variety of the vehicles. Now let's speak about this transfer station. According to the Ministry of Urban Development, in large cities where destination points are more than 15 km away from the collection area, it is economical to set up a facility such as tertiary storage depot to save the transportation time and fuel. The facility can also be equipped with material recovery facility where recyclables are sorted and sent for further processing or to recyclable markets. This particular facility is called as transfer station. Here you can see in this particular definition sketch that this is the place of generator. This is the primary storage from west, from where that waste is transported to community bin. So this is some secondary storage. From this particular secondary storage, the waste is collected, hauled by making use of some kind of the vehicle which will travel to some common station where the waste coming from such various community beings will be stored together, from where now one will be going for bigger transfer truck. In turn, this particular vehicle will lead to the various destination points, which could be disposal station or processing station. Hence, this particular transfer station facility is meant to store the collected solid waste temporarily. It is a point at which the solid waste is transferred from smaller vehicles to certain bigger vehicles, and this is a point beyond which the cost of direct hauling of the solid waste from collection point to the destination point will be more as compared to the cost of transfer station, its establishment cost, as well its operation cost. And based on this principle only, Ministry of Urban Development in its manual mentions the distance of 15 km. However, as mentioned here, this particular transfer station could be simply a station which is meant for transfer of that particular waste or storing that particular waste, and this kind of the facility could be involving other centers like processing facility, recovery facility, and similar stations. Hence, this particular transfer station could be varying significantly in size as well as its function that could be taking place within the premises that is meant for that particular transfer station. As we focus simply on transfer station, here we wish to have four various operations. As you see here, the vehicle checks in, it registers itself, it gives the essential information, then the weighing of vehicle takes place. I hope you remember about the quantification of the waste, characterization of the waste that we discussed in our earlier presentations. So in order to collect that kind of the data, here the weighing of the vehicle is very much essential. As well, the further part is to know what kind of the material is brought within, what kind of the waste that the facility is expected to deal with, and hence the waste will be studied in view of its components, its particle size, its physical characteristics, its chemical characteristics, in addition to certain the hazardous nature. Hence, the third step is inspection of the waste. As the variety of the waste are coming at this particular transfer station, and this particular facility can also club the other activity like recovery, material recovery, energy recovery, or certain processing station. Simple recycling facility can also be provided for even some common public. So here such drop boxes will be giving some designated points meant for some definite natured waste. So as we try to discuss the basic definition as well as activities, now it is clear for us that this transfer station is kind of centralized facility. It is expected to increase the efficiency of solid waste management. It can also be integrated with the other waste management options as we are involving additional facility, in turn again involving variety of machinery as well as variety of the people. Obviously, it will be involving significant capital as well as operating cost. We can think of some common criteria in order to establish the transfer station. So its location should be nearer to the collection area which it is serving. So this will minimize the collection crew time for haul to the transfer station. It should be accessible to the major haul routes. Here we wish to have the transfer hauling cost reduced. It has to have adequate land area to provide the isolation. It should go with certain suitable zoning like commercial or industrial. It must have enough segregation from the residential locations. As this particular facility serves number of other functions, it should also be equipped with water, sanitary, sewers, even the storm drainage and electricity facility. As far as the transfer station campus is concerned, we wish to have that facility self-sufficient. This is a point at which we can understand the advantages of this particular facility. As you see here, the facility provides better hauling roads for the collection vehicles. Usually being the facility paved, it reduces the damages to the vehicles and also the impact on the environment is less. The delay associated with the traffic congestion is also reduced. One can have the better traffic control as it avoids the traffic jams. As well, the facility being the closed, it is free of littering. Also, it is safe for commuters. As we saw in the definition sketch, the collection vehicle is quite small as compared to the kind of the vehicle which leads from the transfer station. Hence, the transfer station onward, there will be fewer truck leading to the facility such as disposal sites. The reduction occurs to 3:1 to 5:1. The entire facility as establishing the control over the various operations to take place. There is improved operative efficiency and also the cost of overall hauling is reduced as number of vehicles are reduced, as well number of the crew is reduced, though the capacity of the vehicle is quite enhanced, the way it is mentioned here, 3 to 5 times. We have already discussed the points for location of this transfer station, but it could also be one of the factors affecting design of transfer station. Conventionally, we can have these 4 points as factors affecting the design of transfer station. So the transfer station could be direct discharge type, it could be storage discharge type, or it could be combined facility, the details of which we will discuss later. Capacity requirement is one of the factors. Equipment and accessory requirement is also one of the factors in addition to environmental requirements. Also, we wish to have this particular design in view of the environmental considerations, essentially focusing on the health and safety as well as the impact on environment. As you see here, we wish to have this particular location placed, so to say, centrally for all the routes coming from various collection points. This must be the weighted center of that particular area in order to achieve the economy. Here you can see that the vehicles that are leading to other facility from the transfer station could be having the capacity of 50 to 75 cubic meters. It has the carriage capacity to 10 to 20 metric tons, and these vehicles are that way quite huge, almost 14 to 20 meter long. Hence, while designing that proper transfer station, a particular location, we also have to take into account the size of such vehicles, the turning radii required to it, the traffic patterns, the driver skills, and even the fuel requirement, workshop facilities required to maintain the vehicles, and such things. Let's understand about the type of transfer stations. Here, there is one small scale system which is termed as direct discharge transfer station. The name itself is explaining about the activity. Here there is a small collection vehicle. Here there is a large capacity transfer container truck and trailer like vehicle. Here there is a hopper placed connecting the level at which the collection vehicle stands and the hauling vehicle. So, as this definition sketch explains, it involves two-level arrangement where the small collection vehicle discharges the waste from higher level into a transfer vehicle parked at lower level. Hence, the number of vehicles approaching, their movement, their capacity, their discharge systems should be in good synchronization with this hauling vehicle. As you see, the waste is directly dumped through this hopper. It could be further compacted and it could be transferred into that container. Hence, there is no need to have any additional sophisticated system for loading the waste. Hence, it does not attract much of the operation and maintenance cost. This kind of a facility is suitable for the waste less than 300 tons per day. So this facility can be termed as medium waste handling facility. Some actual presentations, establishments at Hyderabad, India are shown pictorially in this particular figure. The another kind of a transfer station is storage transfer station. So the way you see here, the solid waste is emptied into the storage platform or pit so as to load that later into bigger transport vehicles to carry the same at different facility. This particular definition sketch explains the integration of other processing facility with the storage type of the transfer station, at which the waste is processed through certain processes and then the remnant is sent to certain facility after its compaction. For such kind of a facility, we will need certain mechanized systems. Here, the storage area should be able to hold the highest receivable quantity for the waste generated in a day. So you know that this waste generation is not static phenomena. We have already discussed the features of waste generation. So this waste generation depends on so many parameters and it is a dynamic process. And as far as present trends are concerned, the waste generation is going to be increased in the coming years. That means one is expected to have this particular waste generation predicted, and for certain design life, this particular area should be designed as well as acquired. Here, the waste unloaded to this storage platform is picked up by overhead crane, or it could be pushed by some such dozers to the receiving hoppers. Also, if these particular crane and dozers are manually operated, the driver can physically see potentially hazardous waste which could damage the transfer vehicle or any of the components of that material recovery facility or processing facility. Hence, the driver can remove and set aside such material. As you see, this is somewhat 3-level facility. So, the collecting transfer trailer is placed at the lowest level. The unloading vehicle is placed at the highest level, whereas that particular pit or the storage area is placed at certain intermediate level. In order to understand the theoretical part with some practical considerations, we can think of certain salient features of transfer station physically existing at Sathi Road, Coimbatore, India. This particular sketch picture indicates how that particular site was before establishment of that transfer station. And the lower picture indicates how that particular scenario is totally changed, look-wise, function-wise. The area is 1.55 acres. The design capacity is 200 tons per day. It is equipped with one stationary compactor. The capacity of the charging hopper is 3.34 cubic meter. It is established at 34 kilometers from the disposal site. The waste could be handled during the peak hour is 70 metric tons. The capacity of that particular station is to handle 35 tons per hour. Here, certain other computerized weighing bridge and such things are having capacity of 40 metric tons. There are not many design alternatives. We discussed about the direct discharge type or the kind of these storage transfer stations. Both of these could also be provided with different alternatives, different design alternatives. So there could be certain tipping floor equipped with open top trailers, wherein there is little site work investment, the building cost is less, it can separate the recyclables. However, this kind of the facility which involves the dozers organizing and push the unloaded waste over the large tipping areas into open top trailers is not much effective as compared to other systems for large volumes to handle. In the similar manner, for various options like pit and open trailers, direct dump equipped with open top trailers, hopper type compaction, push pit compaction, stationary compactors with roll-up containers. You can just go through the various advantages and disadvantages. The matter given is self-explanatory. Here, I wish to make it clear that we just not relying on that direct discharge or the storage discharges, but we can have the other design alternatives which could be having some distinguished advantages and disadvantages. So by studying that, one can devise another alternative or select out of the available options listed here. So the second factors out of the discussion we started from, which is following the type of transfer stations, is capacity requirement. While deciding this particular capacity, we wish to reduce the waiting period in order to have the vehicular capacity effectively utilized. Hence, in view of these particular capacity requirements, the transfer station can be expressed as small, medium and large. Small means which has capacity to handle less than 100 metric tons per day. Medium means 100 to 500 metric tons per day, and the large facility will handle the best more than 500 metric tons per day. While deciding these particular capacities, there is a necessity to have some economic trade-off analysis done between the cost of infrastructure and the cost of operation. Also, there is a necessity to pay attention to these particular equipment and accessory requirement for the transfer station. As you know now, the transfer station could be having the variable capacity as well as it would be having variable functions, in addition to simply transferring the material from small vehicle to larger vehicle. Hence, what kind of the activity we wish to club with, there will be need of additional equipment and accessory the way that is presented in these particular sketches. So there could be need of the mowing floors, there could be need of certain tilt frames, there could be need of hoppers, there could be need of compactors, there could be need of certain overhead cranes and subsequent conveyors. So all that particular things needs to be additionally provided for the transfer station. There is a necessity to monitor this operation and subsequently develop the waste management system depending on the stream of waste being received. In addition, certain equipment may have certain duration, certain life, certain cost, certain serviceability, requirement of the spares, availability of the experts to handle that. So, in line of such engineering data, the equipment and accessory requirement for a particular transfer station will be defined. In addition, we discussed about the public acceptance. We discussed about the zoning requirement. We also discussed about the vehicular usage and related maintenance, and even the emissions causing the air pollution. As such, even in line with the operation and maintenance, there is a necessity to consider environmental requirements. In the simple words, we wish to avoid the littering of the light material. We wish to avoid the accumulation of rubbish. We wish to avoid the nuisance caused because of the littering of the waste, its biodegradation, and also emission of obnoxious gases and particulate. There are many costs that are associated with the establishment of transfer station facilities. So there could be capital cost, so cost of vehicles, garages, administrative services. Also there would be interest cost of debt, which could be because of acquiring the construction facilities as well as equipment. There could be costs that are associated with the labor, various spares, oils, tires of vehicles, and such things. Employee benefits, salaries of temporary employees, certain overhead costs for executives, support staff. The costs which are associated with the budgeting, accounting, as well as report preparations. The costs that are associated with the billing and collecting the user charges, liability and damage claims, and also personal facilities and equipment insurance premiums. So, for such facility, there is a necessity to take into account variety of direct as well as indirect costs. We can have certain economic comparison of the transport alternatives which are indicating the direct hauling of the waste to certain processing facility or the facility which is associated with the establishment of transfer station. So we wish to have certain break-even time corresponding to which the setting establishment of transfer station will prove to be economical as compared to direct hauling of the waste. So for that, we are assuming some certain data. So here, certain transportation costs are given, other costs are given, and in addition, some other data is also given. We can work in certain way. So in a step 1, Say for direct hauling, which is involving certain stationary container system, we can work out the transportation cost in terms of rupees per ton per minute. So the steps that are followed are very clear. This operating cost comes to be rupees 3.42 per ton per minute. For our convenience and to arrive at the solution, we have considered certain random time of 100 minutes for which such variable cost is worked out as rupees 342 per ton. The transportation costs associated with the transfer station can be worked out here. This operating cost is worked out as rupees 1.39 per ton per minute. So these two costs are variable costs which are associated with the actual carriage transport of that particular vehicle. As the transfer station needs certain place, as it needs the facility equipped with a variety of machine as well as a variety of the people, their benefits and the various costs that we had view on previous slide. For that, whether we operate it or not, we can work out the cost as fixed cost, which is also called as amortization cost. So this operating cost works out to be rupees 160 per ton, whereas on that particular transfer station, the unloading costs work out to be rupees 20 per ton. Hence, the fixed cost works out to be rupees 180 per metric ton. So for such kind of computations, we can have the plot of the data that we have arrived at as cost per metric ton associated with round trip driving time to the disposal sites. So the way you see, at 0th moment, for stationary container system, there is no cost towards the transportation, towards the direct hauling, hence it would be 0. Whereas, the way we have worked out for 100 minutes, it is 342 per ton, hence we can have this red line representing stationary container system with direct haul. When we consider the option of this transfer station, there will be fixed cost of 180. Hence, the variable cost is to be plotted that point onward, and this dotted line represents the cost associated with the transfer station. At a particular point, the way you see, both costs will be one and same. So here this particular point gives break-even time of 88.67 minutes. So beyond which the cost of stationary container system will be more as compared to cost associated with the establishment of transfer station and its operation. So we have to select the distance associated with this break-even time by giving consideration to the local traffic conditions, land availability to set the transfer station. The same approach can also be studied by giving consideration to devising some expressions. So say here the cost of direct hauling to the destination point from collection station per unit mass of solid waste, say it is KD. So it can be determined by multiplying the unit cost of direct haul per unit mass of the solid waste per unit time with the time. Hence KD is equal to KHD times T. Now when transfer station is expected to be constructed, the cost involved would be operating, amortization and hauling. So say this KFT is the cost which is representing the sum of operation and that required for the amortization in terms of rupees per unit mass of solid waste, and KHT is the cost of hauling per unit mass of solid waste per unit time. Hence, this KT, which is hauling cost using the transfer station, expressed as rupees per unit mass of solid waste, then it can be put up as KFT plus KHT times T. In order to have that particular break-even time, we can equate these both equations, and as we solve for T, we are getting this particular expression. So, as discussed for earlier problem, since using a transfer station will afford the operator the opportunity to utilize a larger transport vehicle, this KHT is expected to be less than KHT. The plot of this particular equation 1 and 2 will intersect at a point which is the break-even point, the way it was presented on our earlier slide. Beyond this point, direct haul to the destination point will no longer be economical compared to when the transfer station is constructed. As we refer to the data for the problem that we discussed on earlier slide, here KHD is 3.42 per ton per minute, KFT is rupees 180 per ton, KHT is rupees 1.39 per ton per minute. So as we substitute here, that break-even time can be worked out as 88.67 minutes. So thanks for your attention. I hope the concepts that I try to discuss for the transfer station are clear to you. As we move further, we'll discuss about the processing of municipal solid waste in our coming presentation. So bye till then. I wish you very happy learning. Thank you.